Good afternoon. My name is Fotis Liarokapis. I come from CYENS, a center of excellence, and today my talk is going to be a bit different from what you saw before. I'm going to be talking about a big European project, which I'm the coordinator. So to start with, the project is called XR4ED, Extended Reality in Education. We cover all types of education from schools to university students. And the aim of the project, which started in 2023, it's finishing this month, is to create a platform, sustainable platform for education using extended reality. So when we started thinking about the project back in 2021, end of 2021-22, we drafted the architecture of the project, which is what you see. I put this slide on purpose because not deliverably, but we forgot an important element which we didn't think at that point. Actually, nobody was thinking about this element which is missing from the diagram. And I suppose everybody knows what it is. This is artificial intelligence. I'm going to explain the main concepts of the main components of the architecture of XR4ED, starting from now. And you're going to see the main elements. AI is hidden in half of these elements. So first of all, we created a secure user management application. What we want to support is we want to support multi-user creation. We want to register both developers, educators, and learners. And we want the platform to be fully configurable. The next thing, which is extremely important for us, is to upload content. Anybody who is creating content can upload their own content, teachers, developers, anybody who is capable artist of creating content for education. It's important to upload the content into the platform. So we're creating a secure platform, as I said, where you can update your details, which is most important for everybody is the licensing model. We have different types of licensing. It can be from open access to partially open access or with full licenses. And of course, all the content is reviewed by us before it's uploaded to the platform. The platform is going to be live at the end of the project, meaning from January 2026. So all the platform is uploaded into a tool which is similar to the Unity Asset Store. We call it Marketplace. And there you can have all the information you want, which is relevant for the application you have in extended reality. This varies from any type of virtual multimedia content, from metadata, text, images, videos, and obviously 3D. I'll show you a quick video how it looks like. This is an earlier version I'm showing you now. So you have a secure login. This is developed from the technical coordinator of the project, a company located in Cyprus called Celloc. And you can scroll down, if you want, in the marketplace. And it's working, as I said, in a way similar to the Unity Asset Store. And you can upload your own product. You can put the name of a product. You can have it hidden if you want, or you can have it open for other developers. And you can either have it for free or even sell it if you want. So you can add a short description for people to look about it. And you can have a much more detailed description about it. So this is the marketplace, which is essential for educators who want to create their own applications using extended reality. One of the most important things, another component, is the authoring tool. The authoring tool is useful for anybody who doesn't know how to create XR applications. So most of the educators have no idea how to program. And the idea is to use the authoring tool in order to create the 3D virtual worlds and then visualize them. So this is a short video which shows you some of the capabilities of the World Builder, which is the application for creating your own virtual worlds. So we have support for a number of different things. You have UI theme support. We have different templates that we have created. Of course, this is highly customizable. Everybody can create their own templates. We have wizards, plugins. We have the editor, and it's very simple to edit your own virtual world. Somebody might ask here, what's the difference from existing platforms? The difference from, there are more than 150 different virtual worlds already outside there. The difference in our applications, we're using more advanced techniques, as you're going to see in the next few slides. So this is the standard things that most of the platforms support. So we have a number of different assets that you can use for developing your own application. We can have a single export, or we can publish it on multiple platforms, iOS and Android. And as soon as you finish with that, you have to run and visualize the application that you created, again, on a multi-platform. So you can have a VR view, which is a single system for beginners, or you can have a first-person view or third-person view. Additionally, you have much more features. You can have multiplayer support. This is common. And one of the main differences that we have is advanced avatars. I'm going to show you some videos later on. And as well as augmented reality application configuration. This is something that is missing in most XR applications that you see nowadays in the market. Another thing that, as I said in the beginning, we realized that we're missing AI was the ability to generate our own content creation. So we developed a tool throughout another partner from the project, Simavi from Romania, where you can create images, sounds, and 3D models, having as an input just a textual word or a sentence. So in this case, you can see the user is creating a pyramid. So by saying, I want to create a pyramid, and then the powerful component of this application is as soon as you create your asset, you can save it to your hard drive, and then you can upload it to the marketplace, and this is going to be accessible by everybody else in the community. So now the developer has saved the asset in their computer and uploading the asset in the marketplace. Of course, you can type more complicated sentences. In the next example, in this video, you're going to see somebody creating a more complicated environment. Not extremely complicated. We're still working on this area, but as you know, the field is moving exponentially. So in this case, you're going to see the user creating a desk with a computer on top. As soon as you log in, you're going to see the 3D object, and you can load the model, and then you can follow exactly the same procedure, save the model in your hard drive, and then you can upload it in the marketplace, which can be used from the authoring tool in order to visualize the content. What is missing from here is the avatars, which you're going to see in the next slides. But we wanted not to have the avatars just like plain avatars. We wanted to use, again, artificial intelligence in order to make the avatars as smart as possible. So we're using standard functionality, Microsoft Azure services. So we're using text-to-speech and speech-to-text services. And we're using the latest version of ChatGPT. So in essence, what we are doing is we have these 4 different functionalities. We're having gestures and animations. We have integrated PowerPoint, so the teacher can upload their PowerPoint in the marketplace and take it from the marketplace, use an avatar, and ask the avatar to do the lecture. What you can see here on the left-hand side on this video is we asked ChatGPT, we put 2 different avatars.
Indeed, there's so much history to discover here.
We gave them a topic. The topic is about the old city of Nicosia in Cyprus.
It truly is a remarkable
So the 2 avatars, AI is speaking to himself, communicating for a few minutes, and then a user, which is actually seeing these 2 touristic guides, in this sense, is going to start asking questions.
Look at that old building over there.
This is done in AR. We use the panorama image.
That's a traditional Cypriot house.
So I'm mentioning about panoramic environment. So it's not done in
Fascinating
VR,
how the
it's an
architecture
AR
reflects the
environment.
culture.
Absolutely. Every building has a
I don't know if
story
you
to
can
tell.
hear the sound. So the two avatars
I'm
are talking
excited to
about the old
discover
city of
more
Nicosia.
stories in Nicosia.
I'm sure you'll find plenty.
Thank you, Costas. Your knowledge of the city is invaluable.
You can limit as long
It's my
as you
pleasure
want
to share it with you, Nikki.
the communication of the AI about the topic.
Hello.
Hello, dear traveler.
Hello there.
So the tourist
we
is making
assist
an
you today?
inquiry now.
Can you recommend any good food here in Nicosia?
Certainly. Traditional Cypriot cuisine is a must-try in Nicosia.
You should definitely try souvlaki, halloumi cheese, and lokomades.
Okay, apart from that, we have started doing co-designing with XR agents using the help of students and educators. So we ran several workshops. We follow traditional HCI techniques in Cyprus, and we got their feedback, and the feedback was extremely useful. You can see the six more ideas that we were provided by the students and educator. So one of the ideas was that the agent totally replaces the teacher. Of course, we're not aiming at all in doing that. We're trying to use the intelligent agents to help the teacher. But there were other approaches, like the agent that makes the code more tangible. This is voted as very high valuable by everybody. The agent that shows you around, I showed you an example about that before, or the agent that trains trainers. Another idea is the agent that extends practice, the agent that helps the teacher. This is our main aim. We want to help the teacher. We want to make the teaching environment more exciting. Or the agent that teaches all subjects. These were the ideas that came from the workshops that we ran in Nicosia. And now moving to another component, which again is something that you don't see in most XR environments that you have around. So we have we designed our own avatar architecture that was done by another partner of the project in Spain. And we're using our own animation system. You're going to see now some videos. You can see on the first video on the left-hand side the proposed inverse kinematic system that we're using in the project, and the standard inverse kinematic system that is used in Unity. You can see the differences. On the right-hand side, you can see another video about doing tracking of the body when you're using only a head-mounted display. As you know, when you have a head-mounted display, you have limitation in tracker, so you cannot track your hands or your feet. So you do an estimation of how your body is moving and reacting. So these are some of the big differences we have in this project compared to other commercial solutions that exist worldwide. Of course, we experimented with different commercial solutions. On the left-hand side, you can see a frame VR customization that we did, trying to use VR in the classroom. This video took us literally a few days of work. On the other hand, what you see here is an application we did based on UBIG. UBIG is an open source platform written in C++, where you need to have coding experience in order to develop applications on top of that. The important thing about this application is that you have the teacher on one hand of the board, whiteboard or blackboard, virtual whiteboard or blackboard, and on the other hand, you have the student. And
you can change the color of the pen and its size.
Both of them interact at the same time, and both of them can see the things, not reversed, but in a proper manner.
Let's go to the other side of the classroom.
So as I said, both teacher and learner are working at the same environment.
This circular camera effect is to reduce motion sickness.
And we use several tricks, like the circular environment, in order to make the the environment more pleasant. Of course, you can export that at the end, you can save it, and you can use it in any application that you want later on. So, moving on, the project had received 3 million euros for the consortium to develop the platform that I just explained to you. And then we received another 4.6 million euros, which we gave to companies all around Europe. The submission was in the 1st of May 2024. We have received 206 applications. And out of the 206 applications, we supported only 20. The requested funding was 4.4 million, and we had specific calls, specific areas. So that, we funded the 20 projects in these 6 thematic pillars: virtual field trips, content creation and exploitation, awareness for climate change and biodiversity challenges, training of young professionals, distance and blended learning, and accessibility and inclusion. So half of the projects developed tools which were binded into our platform. So we also have, for example, haptics. And on the other 10 calls, we gave the projects to pilots, which validated the platform. And these are the winners of 20 projects. And you're going to see them in booth 501. All of the 20 projects will be demonstrated tomorrow and on Wednesday. So you're more than welcome to come and visit the results of this project. Thank you very much.